Data structures. My name is Yemi Adeniji. Today we will be discussing sorting. Data structures is actually the organization of data or information that is most of the time found in the computer memory, and this is done in order for us to be able to have a better algorithm efficiency. This type of data structure, we have queue, stack, linked list, we have heap, dictionary, and tree. Sometimes we can also talk about binary search tree, and also conceptual unity, and this is referred to as name and address of a person. An example include the length of a list of the number of nodes in a subtree. Meaning of sorting. Well, we need to understand the meaning of sorting, the process in which data are arranged in a particular manner. That is sorting. For example, say we are given a list of numbers and we want to arrange the elements of this list from the largest to the smallest, that is in decreasing manner, or from the largest to the smallest, or from the smallest to the largest, that is in decreasing or ascending order. Of course, we have different types of data, that an object that can be arranged in a specific order, and we have different reasons for doing this. Reasons for sorting. An instance is if we want to obtain the highest score in a test from the student, we need to do sorting in order to obtain the highest score of a test and know the best scorer in a class. Another reason is to ascertain an organization's biggest client based on sales. In an organization, say in a bank or financial establishment, they decide to know the best customer that they ever had. They can do sorting in order to make them know who is actually their biggest client, their best customer, based on the sales that they have made from such client. Another reason for sorting is the database of people's ID. If there is a database of people's ID and is being arranged in an ascending order, say from 1 to 10 million people in this community, okay, that's another reason in which sorting might be done. If we want to obtain the top 5 oldest in age, sorting is required. We are with a group of people and we want to know the senior citizen, we want to know the top 5, we might need to do some sorting of the age that is given to us. The best and top 5 highest achievers based on scores. In a given class, say in a college or in a class, we want to know the best achievers. The only way that we can achieve this or do this is by sorting. We have to sort the highest achievers based on their scores from the given examination. That means sorting is also required. Again, sorting enables efficient searching algorithms such as binary tree. In the concept of binary tree, we can do binary search tree in order to allow us to be able to sort data efficiently, that is more effectively. Immediately we see the binary search tree, we already know that the data there are already sorted. So that's another reason for sorting. Next is sorting methods. Of course, we have different ways in which sorting can be done. We have different methods. Well, sorting makes use of selection statements, loops, methods, and arrays in a means to demonstrate algorithm performance. What this means is, during sorting, repetition always occurs, that is, there is recursion of comparing two elements to the other. Sometimes we need to compare and swap. Sometimes we need to just compare from left to right two elements if one is lesser than the element or not. And this keeps on going on and on until the whole list is what has been visited. That is why it involves the use of loop statements or selection statements. There are several sorting methods, like I said, and the common ones are the bubble sort, selection sort, insertion sort, quick sort, and heap sort. We have some others, but let's just talk about the common type of sorting that we have. Bubble sort. Well, when we talk about a bubble sort, it's a simple sorting algorithm, and this happens in such a way that two elements are compared, in which the first two elements will be compared, and the second and the third elements will also be compared until the end of the list. But when the comparison is done, if the first element is larger than the second element, a swap will occur. That is, say for example 2 and 9 are the two consecutive elements in a given list. Then 2 and 9 is compared, and there is no swap necessary in that example because 2 is lesser than 9. But let's say we have 5 and 4. In such instance, 5 is the first element and 4 is the next element. We compare 5 to 4. Is 5 lesser than 4? Yes. Then a swap will occur. Then 4 have to be moved to the left and 5 to the right. That is swap. So we compare and swap when applicable in bubble sort. And a bubble sort time is big O of n raised to power 2. That is, it is quadratic in nature. Well, let's check out how bubble sort works. We compare and swap, like I explained, if the next element is smaller to the first element. On the screen, we can see a list that is given as an example. We have a list of 6 elements on row 1. 2, 9, 5, 4, 8, 1. These are the lists that are given. Using bubble sort, we are supposed to compare the first two elements, which are 2 and 9. Is 2 lesser than 9, or is 2 greater than 9? 2 is lesser than 9, so there will be no swap because the 2 is lesser than 9. Then we move to the next two elements, which is 9 and 5. Is 9 lesser than 5? No. So after comparing 9 and 5, they are in green color. Then a swap is expected on the first pass. So we have to position 5 in front of 9. So the next line on the row 2 becomes 2, 5, 9, 4, 8, 1. Because 5 we have to be swapped with 9. The next move is to compare the next element, which will now be comparing 9 and 4. Okay? Because 9 and 5 has been compared and a swap operation has been performed. So we have to check 9 and 4. Those are the two consecutive elements that is next on the list of the array. So we have 9 and 4. Is 9 lesser than 4? No. Then a swap is required. So that is why on the third row we now have 2, 5, 4, 9, because we have to compare 9 and 4 and a swap is necessary. Then we have a new list. The next comparison will then be between 9 and 8, in which we ask the question again, is 9 lesser than 8? No. So since it is not, a swap operation is required. Compare and swap. That is bubble sort. Then we have to put 8 in the position of 9, and 9 goes to the position of 8. That is the swap. Then on the fourth row, we have the new list. 2, 5, 4, 8, 9, 1 will be the new list. Then there are two more elements to compare. In this pass, we have 9 and 1. Is 9 greater than 1? Yes. Then a swap is required because it has to be lesser. The element needs to be lesser than the consecutive one that is next to it. Then a swap operation is required again. Then that is why we have the new list on row 5 to become 2, 5, 4, 8, 1, 9. So 9 and 1 has been swapped. And that is why we have 1, 9 in green color as the last two elements of the list. So that is the end of the first pass. It is called passes in bubble sort. We have been able to compare and swap all the elements of the given list at the first instance, and this is called first pass. So then after the first pass, we need to check the element and see if it has been fully sorted. But in this instance, not yet, because the resulting list from the sorting using bubble sort is 2, 5, 4, 8, 1, 9. Then we have to go to the next column and continue with the pass. Okay? So in this instance, we start again, compare and swap. We compare 2 and 5. Is 2 greater than 5? No. Then a swap is not necessary. Okay? The next two elements that we need to compare on the list is 5 and 4. In this instance, we ask the question again, is 5 lesser than 4? No. Then a swap operation is needed. So the next move is to swap 5 and 4. So 5 goes to the back and 4 comes in front of 5. Then we have a new list, 2, 4, 5, 8, 1, 9. On the second row of the second pass, we can see 4 and 5 are in color green to show that a swap operation has been performed. Then we move to the, we now check, before we move to the third row, we need to check again the next two consecutive elements that has not been compared, and that is 5 and 8. So, is 5 less than 8? Then we say yes or no. Yes, 5 is less than 8. So in this instance, swap operation is not necessary because 5 is already in the correct position. The next comparison will be 8 and 1. Then we say, is 8 greater than 1? The answer is yes. Then we have to swap because the first element of the consecutive one should be lesser than the next element in the list. Because 8 is then greater than 1, we have to swap. Then the new list on the fourth row becomes 2, 4, 5, 1, 8, 9. Then we can now say the swap operation has been performed. Before we now go to the next pass, we check the last element on the list. We have two more elements to compare. We need to compare elements 8 and 9. And is 8 greater than 9? Yes. 8 less than 9? Yes. So, a swap is not necessary. Then the second pass has been completed because we have been able to move to pass from the first element to the last element. Okay, but the resulting output is not actually fully sorted. Then we move to the third column to do the third pass. So we check, is 2 lesser than 4? Yes. Then a swap is not necessary. We compare 4 and 5 again. Is 4 lesser than 5? Yes. No need for swapping. The next two elements that we need to compare is now 5 and 1. Okay. Is 5 lesser than 1? No. Then a swap operation will be performed Then we can now go to the next list. We have a new list in which we have 2, 4, 1, 5, 8, 9. And in this instance, we can now compare 5 and 8 and 8 and 9. Is 5 lesser than 8? Yes. A swap is not necessary. Is 8 lesser than 9? Yes. So there is no need for swap operation. Then we can now move on to the fourth pass. The fourth pass is 2 lesser than 4. Yes. Then a swap is not necessary. So we do the same operation until the fifth pass. Thank you. Then on the fifth column, we can now see that 2, 1, 4, 5, 8, 9 are the resulting lists in the array. So we compare all the elements. 2 is greater than 1, so a swap is necessary. We compare 2 and 4, no swap operation necessary. Compare 4 and 5, compare 5 and 8, and we compare 8 and 9. At this point, we can now see that there is no need for any swap, and the element is already sorted. So that is how bubble sort works. Thank you. Selection sort. Selection sort is another type of sorting, but in the next class, we'll continue with selection sort. Thank you for watching. See you some other time. Cheers.